Okay, we are going to look at the topic expressing calculator notation as scientific notation. This can be found in the exponents, polynomials, and radicals pie slice of your ALEX program, and is a little weird because I think a lot of you are seeing this and probably not entirely clear about what scientific notation is and why we need it. So I just wanted to quickly talk about that before I do the topic. So the why of scientific notation is I'm going to kind of explain that to you right now. So for example, if I am talking about the distance from Pluto to the sun, right? And I have this number right here. I have 591 billion meters. Right now, if I need to do something with that number where I need to like add it or subtract it to something else or compute or write it down or anything like that, the problem is I don't want to be writing zeros all day long. And there's 9 zeros in this thing, and this is a relatively small number compared to some of the numbers that they talk about when you're dealing with outer space. So this is like I said, this isn't even like a typical example. If you're talking about the distance of a star to Earth, you're talking about huge numbers more, right? So for this, the whole point of scientific notation is for us to be able to write this in a concise and easy way. So what we do with scientific notation is you write it as a decimal with only one digit in the ones place. So what you do is you start where the decimal is right now, right? And you would go, okay, let's go 1, 2, 3, and then we go another 6 places, and then 9 places, and then another 2 places. So we go 11 places, and then we write it as a decimal, and we go 5.91 times 10 to the 11th power, because I moved that decimal 11 places to make it into this. So this is a nice, concise, and easy way to write this number. Looking at it this way gives you a better idea of just how big it is. But if you have it this way, it's a lot easier to work with, right? And it's called scientific notation because it's used primarily in scientific applications, especially in chemistry and physics. All right, so now let's look at this. So if I have the diameter of a helium nucleus, right? So now we're talking about something that's extremely small, like so small you could never see it with the human eye, and most microscopes that you will work with in your lifetime will not be strong enough to even detect this. So we're talking small, and it's written in terms of meters, right? And you think about how long a meter is, right? And then this is a fraction of a fraction of a fraction of a meter. So if we're going to do the same approach this time, except we're going to be going the other direction, which means our exponent is going to be negative. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I want to go one more place so I can make this a number that's like a single digit number with a decimal. So we went 15 places. So we're going to write this 3.8 times 10. And now because I went this direction, I went the other direction, it's negative 15. So this is a very, very, very small number, right? Like I don't even know how to describe it. It's so small, right? A fraction of the head of a pin. All right, so this is 3.8 times 10 to the negative 15 meters. And again, we use things like this so that we can use them when they're using certain formulas or whatever in scientific applications. And that's primarily where you're going to see this. So the topic now, so getting to the topic. So the topic says, suppose some computations were done on a calculator. The result displayed for this first one, right, for A, this is letter A, was 5.196 E negative 27. So this is written in a simplified version of scientific notation specifically for calculators because they can't really show exponents in a nice way on calculators, right? They don't have that way to go like, well, here's 5 to the 7th power. They can't use those superscripts, right, which is what an exponent is. So they write it using this E. So what this means, and the way you change this is you would then write this as you'd say, okay, letter A is going to be 5.196. It's already converted for you. I got to get my 1 in there. 5.196. It's converted already basically for that. And it tells you what your exponent is. Your exponent is the number that's just to the right of the E. So my exponent is negative 27. So it's times 10 to the negative 27. So really the only thing you're adding is you're adding this multiplication sign and you're adding the 10. And then you're putting that in place of the E. So the E stands for times 10, and then you put that number that's right here goes in there. All right, and so letter B is going to be 8, and then the E stands for times 10, and then my power is 21. And so that's a huge number. That's an 8 with 21 zeros after it, right? So that's a really, really big number. All right, let's look at one more. All right, so this first number, 3.54 e to the 23rd power, is, again, if it's already written in the decimal form, leave it. So 3.54, and then the e stands for times 10, and then we put 23 as our power. So we put that up there. Letter B, same thing, 1.8. E stands for times 10. And then my power on this one is negative 38. So you got to make sure you have that negative up there. So this is a extremely large number, like extremely large, and this is unbelievably small. This is like if you took a little whisker off that the diameter that we were talking about. So it can't even compare it. It's so small, right? So are things in real life this big and small? Yeah, but they're so big and so small that we can't comprehend them. So we use scientific notation for those because it's just easier and a lot quicker to write it out. So I hope this helps you with the topic.